All right, if I wanted to figure out the number of permutations of the letters A, B, and C, this is the number, when I say the permutations, I'm talking about the number of ways I can arrange things. So in the number of permutations of A, B, and C, this would be 3 permute 3. I'm going to use this NPR notation rather than the P whatever notation because it's too easily confused with probability. Also, this is the way it looks when you plug it into your calculator on the graphing calculators. So that's why I'm doing it this way. Actually, it's that same way on the TI-36. So yeah, like I said, I'm going to do it this way. So 3 NPR 3, which is the same as 3 factorial. That's just 6. 3 times 2 times 1. I just have that memorized. I don't feel it's really necessary to plug into the calculator, but you could easily know. All right, find the number of permutations of the letters A, B, and C if only two of the letters are used. So we're saying we have 3 letters, and we're going to only permute 2 of them. So 3 NPR 2. Well, this one is going to be 3 factorial over 2 factorial. No, that's not right. 3 factorial over 3 minus 1 factorial. 3 minus 2 factorial, there we go. Whatever. I said I wasn't going to use those. I'm not going to use those. Let's just do 3 permute 2. You can see that's still 6. You can actually kind of reason your way through this. I'm using permutations because it's a good idea to get in that habit, but you could have just used the counting principles we used before. 3 times 2 times 1. I have 3 different ways that I could choose the first letter, 2 different ways for the second letter, 1 different way, only 1 way for the third letter. Here I'm just doing 3 times 2. I don't care about that third one, but I'm multiplying by 1 up here, so it doesn't change the value anyway. So if I'm only using 2 of the letters, it's the same as there's the same number of ways to do as if I'm using 3.